Graph the following piecewise defined function. Indicate whether the endpoints of each piece with a closed or open dot are included on the graph. So you should be comfortable at this point graphing functions, lines, and constant functions at least on restricted domains. Because if you are, then graphing a piecewise function is no big deal. Because if you'll notice, over here, we have two restricted domains. One is where x is less than or equal to 3, or less than or equal to -3. So starting here and going back this way. So that's that domain. The other, which I'll do in a different color, is where it's greater than 3. These two do not intersect each other, which is good because the thing is, the individual graphs, so for instance, if I had -1, that's a constant function here, just a horizontal line. And then I have x plus 1. So that's just a line that is slanted, it passes through +1, and it has a slope of 1. So I'll kind of sketch that there. Now, the thing is, what I've drawn fails the vertical line test at every single point, because every single point there's a vertical line that this function has two output values for. So that can't be the graph. And the difference is these restricted domains. So the restricted domain for the line is that it starts at -3, so this line actually only starts here and goes this direction. None of this part of the line actually exists. When it comes to the horizontal line at -1, the domain starts at -3 and goes to +infinity. So only these points exist. None of these back here exist, so those go away. So in effect, this is what my graph actually looks like here. And it does pass the vertical line test at every single point. Now, to graph this in your homework system, what we need to do, use the tool set that's available, and generally what I will do is take these boundary points, plug those in, and get them plotted first. So if I take -3 and put it into this function, -3 plus 1 is -2. And then it has a slope of 1. All right, but a slope of 1 generally would look like this, where you go up 1 over 1. But you can also go down 1, back 1, and that still gives you a slope of 1 as well. So that's that piece. And then the other piece is where x is greater than 3, we have a horizontal line like that. And don't worry about those red squares looking like they filled in your open circle. If you click the dot tool, you'll see that it hasn't. And if you hit submit, here we go.